this video. So, you know what? I was really thinking about something and I wanted to provide a video for it as well. It really doesn't have anything to do with necessarily patterns per se, but it does something that works over and over again. So it's loose, but it's going to work. And because we're talking about atomic radius, I think it works even more. What about ionic radius? Now, ionic radius is referring to the size of ions. And again, ions can either be cations, which are positive, for example, the metals. Okay. Now, I'll do it. And some nonmetals over here that are mostly negative. Again, not all of them are. I think it's a fair estimation to make. And as you can see here, these guys with positives are all smaller than their original size. And you can see here, fluorine, chlorine, bromine, iodine, they get bigger with the ion. So, kind of simply put, these get big, and these get small. Well, why is that? Well, I think the easy way to think about it is really with the cations. So, for example, if you have something like, I don't know, lithium, right? Lithium has two shells. And there's electrons on these shells. So, for example, if we have lithium, we're going to have, and I'm going to just go back to normal pen really quick. You're going to have an electron here. You're going to have an electron here. And you're going to get an electron here. So again, I'm doing this one right now. Well, as you can see, well, I'm lithium, and lithium is a +1 charge for diamond. All these pluses mean +1. The one's invisible. Well, I'm trying to lose one electron, so if I lose one electron, do you see how I just lost my outside layer? Check this out. If you lose this electron, you lose that whole layer. You get smaller. That's why. If you lose your valence electrons, it's like taking off a coat. You're going to be smaller looking with, one put on instead of two. And here, you're gaining electrons. So if I were to do this with a nonmetal, right? Let's say that I have, fluorine. I think that's maybe the easiest one to talk about. And just this. Fluorine's going to have a whole bunch of dots on it. One. Oop, that's a terrible dot. 1, 2, 3, 4, 5, 6, 7, 8, and again, not perfect, 9. Well, fluorine -1, if you're gaining an electron, there's your 10th. But what ends up happening, again, with all of these, is that as you add the 10th, it allows it to expand. And that's because, even like babysitting. If you have 5 kids you're babysitting, you can keep those kids pretty close to you. But if you add on 2 kids and make it 7, that's 2 more kids you have to worry about. So it kind of gives the kids a little more control. Because with 1 kid, you could just stay behind them the whole time. They're super close to you, all that. But if you add kids, the range that they can go where you can kind of stay in the middle of all of them gets bigger because it's harder to control. Same thing here. Think of it like a war. With fluorine having 9 protons, it can handle 9 okay. It really can't handle 10, so that 10th electron pulls out a little bit more, just like the war. So all cations are smaller, all anions are bigger.